Now consider this question. The table shows the electronic structure. There are some elements and the electronic structure is given in front of it. The element P, it has the electronic structure 2 and 6. Element Q, it has electronic structure 281. Element R, it has electronic structure 287. And element S, it has electronic structure 2, 8 and 8. Now we have a question. Identify which element form covalent bonds with the carbon. In the given elements, we have to identify which of the element can able to form covalent bonds with the carbon. Now, as we know, carbon has the atomic number 6. So its electronic configuration is 2 and 4. And from the electronic configuration of carbon, we can observe easily that in the outermost orbit, it has 4 electrons. That means it needed 4 more electrons in order to form the covalent bond, in order to form the sharing, in order to form the octet. Okay. So carbon can share 4 electrons with other elements if that other element contains either 4 electrons in the valence orbit, either more than 4 electrons in their valence orbit. Now, when we consider the case of the P, here we have 6 electrons in the outermost orbit. That means from the P, carbon can share the 4 electrons from the 6 because 6 is greater than 4. Now, in the case P, it can form the sharing because it has 6 electrons and carbon needed 4 electrons to share. Okay. Now, if we consider the case of Q, it has 1 electron only in the outermost orbit. So, it is not able to share 4 electrons with the element Q because there are less number of electrons in the valence orbit and the carbon needed 4 electrons for the sharing. So, Q, it does not form the sharing. Now, for the R, it has 7 electrons. Here also, it has more than 4 electrons. So, in the R, it can also do the sharing and can easily form the covalent bonds. Now, if we consider the case of S, already it has 8 electrons, more than 4 electrons. But in the octet, from the octet rule, if any element having 8 electrons in the outermost orbit, its octet is completed and it is unreactive. So, in case of S, carbon does not share with it any electrons. So, in this way, from the above table, only P and R can form the covalent compounds with the carbon along the sharing of the electrons. Okay. Now, the second part of the question we have, the carbon reacts with elements in the above table to form several compounds. That means carbon has a property to form several compounds. Give reasons. That means this is a theoretical question and we have to answer it, that why the carbon is able to form a lot of compounds. So there are 2 reasons why the carbon can form several compounds. Number 1, tetravalency of the carbon. Now, what is the tetravalency of the carbon? That means, as we know, it has the electronic configuration 4. That means carbon has 4 electrons in its outermost orbit. So, it is a tetravalent compound, tetravalent element and can easily form lot of compounds by just sharing the 4 electrons. Okay. So, tetravalency of the carbon makes it possible to form the several compounds of the carbon. Second one, carbon has a unique property which is termed as catenation. Now, what is the catenation? Catenation is the property of the element in which the element form compounds just by self-linking. We can see that catenation is a self-linking. That means carbon and carbon, they attached by their self. That means each carbon atom, they It also has 4 electrons in the outermost orbit. It also has 4 electrons in the outermost orbit, and they share their electrons, and in this way carbon form a long chain. That means the property of self-linking of carbon elements leads to the formation of lot of compounds of the carbon. So after that I am going to explain another question which is very important for the board examinations of class 10th, and I am going to explain you one by one a lot of questions. But if you want to purchase the whole of the lesson, whole of the course, or even the sample papers, just dial the number which is running on the screen, or just WhatsApp on it, and or you can purchase the whole course just by clicking on the link which is given in the description box. Now the next question is, how will you prove that C4H8 and C5H10 are homologous? Now this question, as we can see clearly, based on the topic of the homologous series. Now here we have to prove that whether C4H8 and C5H10 are homologous or not. So firstly we try to find for any homologous series in which functional group or in which series they can belongs. Now firstly we observe C4H8. Okay, that means carbon molecules here are 4. Now we can easily say that there is no functional group like alcohol and aldehyde, etc. There is no functional group. Now we can check over here whether they belong to alkene, alkene or alkyne. Okay. Now as we know, alkene has a formula CnH2n plus 2. Alkene has the formula CnH2n, and alkyne has a formula CnH2n minus 2. Now in substituting the value of n, we can easily find that if we find n is 4, now 4 2 is 8, 9, 10, but we have C4H8. Now if we put over here C4 2 is 8, it belongs to alkene group. So we can easily find that C4H8, it has the general formula CnH2n. That means it belongs to alkene group. Okay. Now as soon as we find this, we can check whether this also belongs to the same group or not. So when we put n is equal to, this is 5, so n is 5. Okay, number of carbon atoms is 5, so n is 5. Now substituting in the formula CnH2n, we can easily get C5H2 into 5, which is equal to C5H10. So we get the same formula. So these two belong to same, both of them have same functional group, that is alkene. Now we can easily see over here, in between them there's a difference of, this is C5H10 and this is C4H8. We can easily see that here is a difference of CH2 group in between both of them. So they have both have the same functional group, and both have the difference of the CH2. So these belongs to a same homologous series. So we can easily say that they are homologous to each other. How many isomers are possible for C4H8, and draw the structure? Now in this question we discuss what is isomer and how we will draw different isomers of the given compound. Now first thing, what is an isomer? So isomers are the compounds which have same molecular formula and they have different structural formula. Okay, isomers are the compounds which have the same molecular formula but they have different structural formula. Now it is given in the case for the C4H8, we have to draw different structural formula having the same molecular formula of C4H8. Now when we consider C4H8, we can easily observe here that the number of compounds of the carbon compounds are 4. Now whenever there are 4 carbon compounds, its name goes like but. Okay. Now after that, we can easily check over here, there is no functional group. So either it is alkene, alkene or alkyne series. So if we check for it, we can see over here CnH2n series. Because when we put 4, 4 2s are 8. So this is alkene one. Okay. So its name goes like butene. Okay. Now we can see here whether it has different isomers or not and what are their different structural formulas one by one. Now these are the 4 isomers which are possible for C4H8. We can see one by one. Firstly, I have taken the straight chain for C4H8. So we arrange 4 carbon atoms one by one in a straight chain. So, but there are 8 hydrogen molecules. So firstly we arrange over 3 and 3, 6 hydrogen molecules. Then we have only left with 2. So we put over here. Now for the carbon atom, we always arrange them with the 4 valencies. Here this is 3 plus 1. So in order to complete this, here we put the double bond. So this is at the place of second position. So its name is what? Butene. 2-butene, because double bond is at the position of second. Now after considering the straight chain, we transform it in this way, or we can write also this in this way: CH3, CH2, CH, double bond, CH2. This is also a straight chain for the butene, but here the double bond is at the second position. 1 and 2, 3 and 4. It is at the second position. So we write over here butene 2. And here the double bond is at the first position. 1, 2, 3, 4. So its name is butene 1. Clear? Okay. So in the straight chain, we have 2 different structures formula in which we can arrange C4H8. Now considering the branched chain. Okay. So 1, 2, 3 and 4 carbon atoms are there. So these are arranged in this way. But if we name this according to IUPAC, the longest chain is this. Okay. Now this is first position, this is second, and this is third position. Now for here, we can see over here, at the second position, there is an attachment of the methyl group. Okay, there is an attachment of the methyl group at the second carbon atom. Okay, at the second carbon atom, there is an attachment of the methyl group. CH3 is termed as the methyl group. Okay, so its IUPAC name becomes 2-methyl, and for the longest chain we have 1, 2, 3, and for the 3 we have prop, and it is at the first position. So prop 1-ene. Okay, so this is the IUPAC name of this, and here these are attached in the form of a ring, so it becomes cyclobutane. Okay, so these are the 4 isomers of C4H8, and this question is very important regarding the board examination. Now next question, a carbon compound A have high melting point and boiling point with the molecular formula of C2H6O. Identify the element A if it is soluble in water and write the molecular formula of 2 homologues of A. Now it is given that C2H6O is a carbon compound. Okay, and we have to identify it. So as the compound is C2H6O, that means it is not alkane, alkene and alkyne. It also have the functional group inside it. Okay, so there are functional groups halogens. So there's no halogen. Now alcohol, aldehyde, ketone or ether, ethanol, ether, ester, these types of functional group may be here. Okay, so we can search it. Now here number of carbon atoms is 2. So if we break it, so it becomes CH3. Now here again CH3 and O is left over. Okay, so we can arrange in this way: CH3, O and CH3. So this is the first compound. Okay, now we can also break in this way: C2H5. Okay, we take it as a whole C2H5. I'm not breaking as CH3. C2H5, then one H and one O is left over here, so it becomes in this way. So here ultimately we get two compounds, this one and next CH3, O and CH3. Now listen over here, any compound which have OH over here, it is the alcohol. It has the functional group alcohol. And here when the oxygen is in the middle, it becomes ether. Okay. Now this is C2, so it is ethanol, and this is ether, so it is methoxy. So in this way, these are the two compounds. Now again it is given, identify A if it is soluble in water. Now as we know that alcohols are more readily soluble in water and they also have high melting and boiling point in comparison with the ether. Okay, so the compound A is the C2H5OH and its IUPAC name becomes ethanol, because for every alcohol we write over all, and here it is C2, so it becomes ethanol. So okay, so the compound A is the ethanol. Clear? Now next question is over here. Write the two homologues. Okay, now how can we write the two homologues? We have the compound C2H6O and we have to write two homologues for this. Now for every homologue there is a difference of CH2 group. There is a difference of CH2 group. So when we add CH2 in this, that is one molecule of carbon is added, that is it becomes C3. Here H2, 6 to 8 and O. This is another homologue of this one. Now next homologue we again add CH2 in this. So it becomes C4, H, 8 to 10 and O. So these are the two homologues of this original compound, that is ethanol. So in this way we solve these types of questions. Study the table and give the answer. These are the 5 elements which are given to us: A, B, C, D and E. And their atomic number is given in front of us: 18, 19, 17, 9 and 6. That is, atomic number of A is 18, B is 19, etc. Which element exhibits catenation? So we have to find which element exhibits catenation. Now what is catenation? Catenation is the important property of the carbon of self-linking. That means catenation exhibits in the compounds which self-linked with their elements and form the long chains, and this property is generally exhibited by the carbon, because the carbon has the atomic number 6 and it has 4 electrons in its outermost orbit. So it's simply self-linked with each other by sharing of electrons and form long chains. So from here we can easily see that firstly, if we have atomic number, we write its electronic configuration. So it is 2, 8 and 8. Here it is 2, 8, 8 and 1. It is 2, 8 and 7. It is 2, 8 and 2 and 7. This is 9. This is 2 and 4. So here This is a octet completed, so it doesn't form any bonding. Now it is 1, so if it has 1, it does not share, okay, it does not exhibit catenation. So but it has 4 electrons in its outermost orbit. So this is the carbon and it exhibits the property of the catenation. So which element exhibits the property of catenation? E. Okay. Now next one, which has the highest electronegativity between C and D? Now what are the electronegative elements? The elements which have more than 4 electrons, that means 5, 6, 7. These are more electronegative atoms, okay, because they attract, they have more number of electrons in their outermost orbit. Now it is given in the question, we have to choose which one has the highest electronegativity, whether it is C and whether it is D. So we can see over here, both of have 7 electrons in their outermost orbit. So they more readily attract electrons there towards them, so they are more electronegative. But here we have to find in between C and D which has more, which is highest electronegative. So we can easily say that for the D, this is the nucleus, these are the 2 orbits only. Here it is 2 and it is 7. Now for the C, there are 3 shells in which the electrons are accommodated. Okay, so it has the smaller size and it has the bigger size. So the element which have the smaller size is more electronegative than the element which has the bigger size. So here the C is the more electronegative than the element D. D has the smaller size, so more electronegative atom is D. Okay, just correct it. Now in this particular question, we learn how to find which type of bonding occurs in them. Now the question is, which type of bond exists in CCl4 and CaCl2? Now next question, which type of bond exists in CCl4 and CaCl2? Now there are generally 3 types of bonding which presents in between molecules. Number 1, ionic bonding. Number 2, covalent bonding. And number 3, coordinate bonding. Okay. Now in ionic bonding, electrons are transferred from one element to another and it is in this form. In covalent bonding, there is a sharing of electrons. There is no transference of electrons from one element to another. And in coordinate bonding, electrons are shared by only one of the atom, and the atom which donates the pair of electrons, that is here the atom A donates both of the pairs to B, so this is the donor and this is the exciter. That means both the pairs of the electrons are donated by only one of them. So there are 3 types of bondings generally formed by the different elements. Now here in these 2 examples, we have to find whether which type of bond is formed. So first case, CCl4. Now atomic number of the carbon we know, configuration 2 and 4. And for the chlorine, we know its atomic number is 6, so 2 and 4. For the chlorine, atomic number is 17. So we have 2, 8 and 1. Clear? Now, here it is carbon and 4 electrons are present in the outermost orbit. And chlorine, 1 electron is present in the outermost orbit. So 2 to 4 to 6, 1, 7, and here it is 1. Okay. Similarly here also chlorine 2 to 4 to 6 and 1. And here also chlorine 2, 4, 6 and 1. And again 2, 4, 6 and 1. So there is a sharing of same number of electrons. In the sharing, same number of electrons from each of the elements. So there's a sharing of 1 electrons between carbon and chlorine. So when there's a sharing of electrons and bonds are formed, then this is the covalent bonding. This is covalent bonding. And here we can represent it as in this way also. So in case of CCl4, we have covalent bonding. Now we check for the bonding which exists between CaCl2. Okay. Now for CaCl2, now calcium, its atomic number is 20, that is 2, 8, 8 and 2. And for chlorine again we have 17, that is 2, 8 and 7. Okay. Now here the 2 electrons are over here and here there are 7 electrons. So calcium donates 1 electron over here to both of them to complete their octet. Okay. So in this way it becomes positively charged and it becomes negatively charged. So there's a ionic bonding. There's a ionic bonding. Because calcium is a metal and chlorine is a non-metal, so there's a transfer of electrons from calcium to chlorine. Okay. So in this way, in case of calcium chloride there's ionic bonding, and in case of CCl4 there's a covalent bonding because there was a sharing of electrons in between them. Now these types of questions can also be asked in the examination, that identify the functional groups, and some examples are given to you. Now what are the functional groups? Functional groups are the somewhat a combination of some compounds. When they attach to the hydrocarbons, the whole of the property of the element gets changed. Okay, so please learn all the functional groups which are in your course, like alcohol, aldehyde, ketone, etc. along with their formula. Now I am just concentrating on this question of the functional group. And one thing again, one more thing I also again want to mention you here. If you want to watch whole of the videos, whole of the content, you can WhatsApp me on the number which is running on the video. Okay. Now over here, we can see that along with this hydrocarbon, OH is attached over here. And here COOH is attached over here. When there is a OH, the functional group is alcohol. Okay. And when COH is, it is the carboxylic. Okay. Simply if we have CHO, then it is aldehyde and many more. Okay. I am not going to explain all of the functional group in this question. Now one more important question which is generally asked in the board examination. What are allotropes and write 2 allotropes of carbon? That means you have to learn the definition what are allotropes, and I'm going to give you a glimpse of that. Allotropes are the elements or the compounds which have same chemical properties but different physical properties. That means all the compounds which have different physical properties and they have same chemical composition. That means same chemical composition. Okay, but they have different physical forms or the physical properties. Okay, for example, the carbon occurs in different allotropic forms. That means diamond and graphite. Both have the chemical composition of carbon only. They both of them have the same chemical formula C. But as we know, diamond is the colorless, bright colored, and it is used for making jewelry, etc. It is the hardest substance. And the graphite, it is the black colored, which is we just use in the pencils. That is the lead of the pencil is the graphite. Graphite is soft and graphite is the hardest, and this is the softest. So they have different physical form. That is colorless, that is shiny, and that is black in color. So they have different physical properties, but their chemical composition is same. Then these compounds are termed as electrodes.